Okay, so we're finally ready to do the actual computation of it. Now, this particular sensor is actually fairly cumbersome to do the computation of. Other sensors and ones that you might have to do for an assignment or a project, you get to just read the data in and then the data is there and you just return the data. There's no additional things that you have to do. But we have additional equations that we have to do here. So I'm going to go back to the data sheet here again. And I'm just going to scroll. Well, actually, I was already there. I'm going to scroll here where they have an example. Now, the problem with this example is there's some errors in the formula here. So there's this what's called pressure compensation, and basically it's having to do a calibration. But this formula here, because it's this part right here, this B parentheses C thing isn't correct. They have a typo there. But if you go down, they actually have an evaluation sequence here on how you evaluate everything. And you know, you could do these one line at a time. You could actually just literally do these things as it is here. So you do C12 first times TADC. You store that as C12 x2. Then you do B1 plus C12 x2. And then you do A1 x1 is equal to A1 times PADC, so on and so on. Now you have to make sure to use the same variable names that you're using in your code, which we'll do when we write it here. And that gets a compensated pressure, which then once you have the compensated pressure, don't ask me why they do 115 minus 50, because that's clearly 65. But yeah, so 65 over 1023 plus 50, and well, you got the compensated pressure there, and that gives you a pressure in kilopascals. Alright, so let's get back to the code here. So I'm going to put this in green here. I'm going to write down the formulas for both the pressure and then the temperature here. So pressure, well, let's first say that my compensated pressure is equal to A0 plus B1 plus C12 times TADC times PADC plus B2 times TADC. Okay? And then the actual pressure is equal to 65 divided by 1023 times P comp plus 50. Alright, so let's do the pressure computation here. Well, first off, I'm going to create another variable here, which again, we should probably put this at the top. I'm going to create a double here, and I'm just going to call this P compensated, P comp, for the compensated pressure. Now I'm just going to go ahead and compute that. So it's just writing the equation down. Now remember, you have to use the correct things we had here. So the way we had named these was underscore A0 underscore coefficient plus underscore B1 underscore coefficient plus underscore C12 underscore coefficient times times, what did I call this? I'm going to scroll back up here, temp data. And I'm running out of room, so I'm going to move here to the next line here. But this would be then times press data plus underscore B2 underscore coefficient times temp data. So that's one big long line there. Now you could do it in multiple lines like the example in the data sheet outlined, but I just went ahead and wrote it in one big line, and of course I ran out of room, so it's on 2 lines, but if I were to actually write this, type it up, it would just be 1 line. And then we're ready to finally compute the actual pressure, but this is finally now where we're going to return this. So we're going to set, remember we have the memory location of where the pressure data is stored, so I'm going to do star press is equal to what's going to be 65.0 divided by 1023.0 times pcomp plus 50.0. So we finally have our pressure data. And the last thing we need is the temperature. Now the formula for temperature, as a side note, the formula for temperature, the reason there's debate is this is not a calibrated temperature sensor, so it's not really supposed to be used for measuring accurate temperature, and it's really used for, as you can see, in getting the pressure and accounting for temperature and the pressure, because temperature will affect pressure. So, but the formula we're going to use here is TADC minus 498 divided by negative 5.35 plus 25. That's the formula we're going to use. It might not give us an accurate temperature. In fact, let's go ahead and erase this right here and change it. Instead of plus 35, let's 25, let's do plus 35. It's these are often off by like 10 degrees C, so we'll just go ahead and change it to plus 35. And if you were wanting this to be an accurate temperature sensor, you basically would have to perform a calibration, taking several measurements and getting what these, and basically perform a linear regression to get a linear model to relate, because that's what this is. It's just a linear model here to relate the TADC to the actual linear curve that you would get. But we're not going to take the time to do that. So we have then star temp is going to be equal to temp underscore data minus 498.0 divided by, and I like to put it in parentheses here, negative 5.35 plus 35.0. And now we are finally done. Now, you can't test your code at this point. I mean, you could compile it, but you can't test it because you don't have the sensor. And again, this is what we're going to do on Friday, is we're going to test these sensors on Friday. I hope to have all of them soldered together. If not, we'll have to maybe share between like lab partners and stuff like that, where we'll have like 2 people share a sensor, and so you can kind of both look on one screen and see like that. But hopefully I'll have time to solder them all together. All right.